I've been using this homework for a while now. Oh no, definitely the tall chair does not work here.
The ergonomics. I just gotta go hunt down another chair.
Yeah, I remember what I need to do. Just come over here.
Nice.
Okay. So we've got this cable and a mouse. Awesome. All right. So the way this one works is, so the array list homework is one of the few boring homeworks I do. The array list exercises, and I'm going to go over these things in turn, as well as give you some functions to get you started with it. But the main thing with this is you're going to be learning two things in this module. The first is just generally about array lists, as they're called in Java. In other programming languages, they can be called something different. Like in Python, they're just simply called a list. Anytime you were, if you did, sorry, in Python, yeah, anytime you used a list, even though it was like using array-based notation, it was an array list. Just Python decided that it was worthwhile to abstract the way arrays work and just simply use array lists instead. The other thing you're going to be learning is generics. You're going to be learning the Java-specific syntax for that, but just because it's the Java-specific syntax doesn't mean it just only exists in Java. Generics are very useful because they allow you to specify, okay, we're dealing with a collection of objects, right? I'm dealing with an array of objects. I'm dealing with an array list of objects. I'm dealing with a tree of objects, a graph. And the entire point of this is much in the same way that you have to type your variables in C and in Java, and that kind of it's both a restriction, right? You can't stuff a double into an int, but it also prevents you from accidentally stuffing a double into an int or a string into an int, right? It both, so it's both an impediment, but also it protects you. In a similar way, this kind of allows you to work off assumptions. I know this list will only contain numbers. I know this list will only contain strings. Okay. So you're going to be seeing a lot along the lines of these notations over here. So the first thing I want to say starting off is that the videos that you should have watched right now, right? There's the first half, which is here's what an array list is, and then the second is here's how it works internally. Here's how we build one from scratch. I call it my array list. One of the things I do see students do, and that they do not need to do, is that they try to use the class I wrote, the my array list. No, we're going to be, for the homework, you're going to be using the actual built-in array list in Java. The entire point of the building my array list is so you can see how it works internally. That's part of that is part of the data structures learning experience, which is seeing how these things work with a pedagogical model. Java has just a much more full-featured version of this. So I'm going to go and introduce these. Yes?
For something like my array list, would we have to know how to construct that on like a quiz or test?
For the exam, I don't make you build it. For the exam, we primarily focus on linked lists. And typically what we do with that is that I might say, here we have a linked list class that we've built. I might give you in the past what I've done is I've given a specialized linked list class. That's something that has it's a linked list with a twist, and I tell you to build the add or the remove method for it.
Okay.
So something like that. But internally it's good to know how those things work internally, but memorization won't necessarily help, right? So we are going to be creating 6 static methods, each worth 15 points. 2.4 is permutation, is by far the hardest. I think it's for most students. In fact, it becomes a bit of a mess. So as a result, I will ask you to try this one out, give it a try over the next couple days, and I will go over it on Thursday. I will give you the answer for this one on Thursday. We will do it in class together. Okay, that will be our in-class kind of exercise to do on Thursday. For the rest, though, you'll be wanting to do them, and I'll go through them in order. I'm going to help get you set up by giving you method headers for the uniqueness and the all methods, so all multiples. But basically we've got these 6 problems over here. First, uniqueness. So for this, you're going to be using a list, and hopefully you remember. Technically, it's going to be an array list that you're going to be passing in, but I like writing them as lists simply because it's 5 less keystrokes. So here, write a method called unique. It takes in a list and returns true if all the items in the list are unique. So this is something. So a lot of these are going to be things you could do with arrays, but we're doing them with array lists, so you get used to the syntax. Okay. So checking if all the items in an array list are unique. The logic for doing this on an array list and this on an array, it's the same logic. We're just changing up the syntax. So all the items are unique if none of them are the same. All multiples. So we're going to write a method called all multiples, takes in a list and a number, an int. It returns a new list, so we're making a second list. We're creating a new list that contains all the numbers from the input list that are multiples. And that's a bit of a mouthful, so let's look at the example. So if you're in this list, we've got a bunch of numbers, 1, 25, 2, 5, 30, 19, 57, 2, and 25. We give them this list, you're given this list and 5. Then your answer should be 25, 5, 30, and 25 because we provided 5, and we're looking for all the multiples of 5 in this. Right, 25 is a multiple of 5, 1 isn't, 2 isn't, 5 is a multiple of 5, 30 is a multiple of 5, 19 isn't a multiple of 5, 57 isn't a multiple of 5. So we're only grabbing the multiples of 25, and we don't care if it's been in the list more than once or not, right? We grab 25 and 25 because there were 2 25s in there, right? Similarly, 2.3 is one of those that basically should follow very naturally from 2.2. Which is that given a list and a size, another int, we're looking for all the strings of a size. So if I give you, I like to eat apples and bananas, I will give you, and 3, I will get eat, and, right? Because there were 3 eats and an and. Is permutation, checks to see if given 2 lists, check to see if they are permutations of each other. Now permutations, there's these 2 kind of math terms that you should know, and most of you will eventually learn. If you're CS, if you're IST, you might not learn them. But when we're dealing with probability and stuff, we like to use these terms called permutation and combinations. If you have a pile of items over here, a combination is basically kind of grabbing an assortment of them, and we don't care what order they're in, right? If I grab red, blue, blue, or if I grab blue, blue, red, 2 blues and 1 red, those are both the same combination. Doesn't matter the order I took them in. A permutation is where order matters, right? So if we shuffle a deck of cards, it's the same deck of cards, but whenever we shuffle it, we hopefully get a different permutation, right? Different ordering. And the order matters because that's what we're going to be dealing people in. So what we're checking in here is to see if we've got 2 lists and seeing if they're different, if they're both the permutations of each other. The way we do that is we ask, hey, does this item for each item, does it occur the same time, a number of times in each list, right? So for example, 1, 2, 4 and 1, 4 are permutations of each other. However, what isn't permutations of each other? Something that isn't a permutation of each other is something like this. A, B, and B, A, B are not permutations of each other. Even though they both have A's and B's, one has 2 A's, one has 2 B's. Make sense? Different amounts. String to list of words is a bit of our wild card here, because rather than taking in a list, what we're doing is we'll be giving back a list. Given a string, it converts it into a list of word. This is also your opportunity for extra credit. It's fairly straight. This is a very easy problem without the extra credit, which is that we just simply assume your given string can be is separated by white space. In other words, just spaces. Or and I tell you how to use the split and how to split it on white space over here. On the other hand, if you want extra credit, you can sanitize. If our input string is hello world, you'll just simply give me hello comma, and then you'll give me the world exclamation point. If you want extra credit, sanitize it. and just give me hello world without any of the punctuation. And it will return a list of strings. So the way we read this notation, by the way, right, is a list of strings, right? And so if you've watched the videos, you should hopefully be familiar with this. But what this permutation says is, what this says is that this is a restriction on the number of types, on what types can be inside of list. And this says we can only put strings in this list. So it will actually cough up an error if you try to give it an integer or something like that. Finally, we have remove all instances, which takes in a list of any type and an item. It then proceeds to remove each item in the list that matches the given item. So here's our, for example, here's our list of integers. 1, 4, 5, 6, 5, 5, 2, and an integer 5. And this removes all the 5s from the list. The list then becomes 1, 4, 6, 2 because it removed all the 5s from the list. Okay? It seems very similar to this, the all multiples, but it differs in a key way. We're not providing a new list, we are modifying the old list. Okay? It returns nothing because it changes the list that was provided. And I give you a footnote saying that this one is very tricky because your first attempt may not work. So whatever you give your answer, you want to test your answer on this one. Test your answer, test it specifically on my input. 1, 4, 5, 6, 5, 5, 2. Those repeated 5s are important. Okay? Make sure that you're 90 points for doing the assignment, 10 points for making sure your code is neat and nice for me to read, and then 5 extra points for the string to list of words. So how do we get these things set up? So let's start with the easier way to set up stuff with generics, which is I'm going to do all multiples first, just simply because even though that's a slightly more difficult problem because of modular arithmetic using uniqueness versus uniqueness, which is just true and false, it's easier to set up in terms of like the way it looks. So what we're going to do over here is we are going to do public static, and this one says we are returning a list, returns a new list of integers. So public static, it returns a list of integers. Okay? And then we call it all multiples. And then it will take in a list of integers. List, lowercase list there, and int x. Okay, and our errors are very simple. They are from, our first errors here are from import. Alt enter to just simply import them on this or highlight it. And then we are promising to return something, and I'm not returning something. The first thing you could do and I always like, no matter what, you always should, whenever you have an error, you should quash it somehow. You can quash it by returning null, which is a bit dangerous, right? So the best way to actually quash this is to say, well, if it's going to be returning a new list of numbers, I will go ahead and create that new list called new list of integers, right? It's a list of integers. We're going to call it, maybe our output is equal to new array list, right? The way you always do this is the more abstract type on the left, right? This is what we learned from inheritance, right? Because a array list is a type of list, we can put it in this list box, right? You could also just simply do it as array list like this. You could totally do it like that, and there's nothing stopping you, but it's just my habit to do it like this. And then we return our output. So now we just simply are returning an empty list. Our answer goes in here. So what this is saying is that this takes in a list of integers. And if this isn't making sense to you, watch the videos when you get home, okay? List of integers. So now we use this notation like this because we know that because of the problem definition, we are getting a list of integers as our input. One common mistake though is that that I find weird, and I think it's arbitrary on the part of the program, on the developers of Java, but at this point it is just law, so they have to do it, is you can't do this. You'd think it could be a list of ints, but because of the way generics are implemented or work, you cannot, you have to put a class in, right? You have to put a class in there, an object type. So we use integer, which is, now if you're unfamiliar with this, in Java, every single type int x is equal to 5 has a equivalent, and I'm going to call it capital X because why not, has a equivalent class. Right? And now it gives me an error for doing that. Why? Because you shouldn't do it like that. Because Java does something called auto boxing and auto unboxing, where it says, hey, if we're using a class, you can just use it like a normal primitive, right? So here, this is an integer, and this is basically a wrapper for this. This basically says, hey, here's a class that has a bunch that can hold an integer, but also contains a bunch of integer-related functions, like you may have used this one before, integer.parseInt. Also contains interesting things like max value and min value in there to give you the biggest and smallest possible numbers for integers. So, long story short, you can treat those numbers like ints, and you can like compare them like ints. For instance, I could do something like list.get0, and I can compare them to x. Boolean, right? And that's fine. It doesn't care because this is there's no conversion that needs to happen. It's automatically doing it. Just kind of how you don't have to create a new string even though a string's an object. You just simply do the quotation marks. Okay. Now, this next one, the uniqueness is what trips people up with the syntax. Public static E. Let's see. I believe I call it unique. Boolean unique. And by default, I'm going to assume that it is. By default, I'm going to simply when you see a problem like this, you should like testing if something is true or false. Always choose one as kind of the default, right? And then try to prove it or disprove it, right? Here, I'm going to assume it's the list is unique, and then I'm going to try to prove that it's not unique. Because as soon as I find two items that don't match, I can say, hey, there's a match here. So not everything in here is unique. So I can just end and return false. Okay. So here's the syntax. Ignore this for now. Public static Boolean list, unique E list. This takes in a list of E's, right? What in the world? But notice that, so this is important to notice here. Notice that this is maybe a bit hard to tell, but notice that the integer over here is black. My syntax highlighter is lighting this up as black. Notice that the syntax highlighter over here is lighting this up with a subtle light green. It's a bit hard to see on your screen, but it is a different color, I assure you, and you'll see that on your screen. This is because it recognizes that this is a generic type. Okay? What we're doing over here is that when we do public static and we put something in over here, and if you forget this, I review this right over here. I review this in these paragraphs over here. Because this can be a list of anything, but what we do know is that it's going to be a list of things of the same type. We can say we want to make sure that this is a list of the same type. So public static E says, okay, prepare yourself, compiler. There is a list of something coming in. There's a generic type in here, and that generic type that we don't know is called an E. You can think of it as like a variable, but for types, right? How you have an int over here, an int x is equal to 5, right? Yes?
Is there a way to make it so that it doesn't have to be the same type? Like, is there
There are fun kind of things you can do. There are a lot of fun.
But it's not like built in like this.
How to say? There are fun things you can do. For instance, I could say anything that, like if we went back to if you went back to the previous example, like with our fox and rabbits, I could do something like this. Which would say this could take in a list of anything so long of any kind of animals, as long as those animals are the same type. think that's another one I can do. Another one that's you'll see commonly built in is and I'll tackle this later, comparable. It's easy. Okay, which part? I think I need to import the E for, I think I have to do it the E way first so that I can compare it. Okay, yep, it did compare. Comparable, come on. Is it comparable or did I misspell it? E extends comparable. Yeah. Oh, it was already there. That's what was going on. E extends comparable E. And you can kind of say, hey, this is any type so long as it's comparable. Mind you, they still have to be the same type as each other. And I forget how to use the wildcard modifier, which shows you how often I use that in that case, in this case. But there are a number of use cases for this where we can restrict the type or extend the type. There's also super you can use there. It's actually quite robust.
Yeah, and I think I know exactly what you mean, because you're trying to see if you can get a list of different kind of data types, right? So like an int, a string. So you're not necessarily going to see that with lists specifically because it's designed this way for like that kind of check. However, you might be referencing instead like an object. In JavaScript, I know for a fact, like you can actually make an array list of objects and then reference each of those objects as fields. So that might be something that you would think about if you're trying to use a list in that sort of way. Just try not to use a specific single data type.
You can use a list of objects, and that is the kind of way you can stuff anything into that list.
Okay, that makes sense.
It's just that you can't assume the type of anything inside. You'll see in the videos where I do that, and you have to start casting things in order. Right, and the entire point of this is to prevent the casting problem.
Okay.
So here, what we're going to do, now this, of course, only assumes that they can be objects. Essentially, this is the only assumption you can make, which is that it's an object, and you've got the object methods like is equals, but it doesn't, but you can use any of the object specific, the objects will use their specific is equal method. So strings will use their string is equal method, which is very useful. So anyway, here we're saying it's a list of anything, and E is that type, which you can do things like E my object is equal to new. Well, we won't necessarily know what that is because we don't know how the constructor works, right? We don't even know if there is a constructor for it. Sorry, a list.get 0. But you can do something like this. E my object is equal to list.get 0, which will say, hey, the first item in this list is going to get stored in this variable. What type is E? We're going to figure that out when the programmer passes us the list. If you pass us a list of integers, internally what we're going to do is we're going to replace all those E's with integers. If you pass us a list of strings, we're going to internally replace all of those strings with, all those E's with strings. Why? Why is this a thing? Because this prevents me from having to write a unique method that for a list of integers, and then a list of strings, and a list of doubles, and then a list. I get one method that works on all of them, and is type safe. Okay, so that's why we do it like that. So those are so when do we know how to do it like this, where we specify the type, versus the type is left kind of blank? Well, in the problems where we know what the type is, like all multiples or all strings of size, we know what the types are going in. We say we're going to be passing you a list of strings, or we're going to be passing you a list of integers. In this case, no worries. You just simply use what it says to use. But if we don't know what the type is, that's when you use this. That's when we use this.
You might run into some situations too if you're working with code that you first touch, and let's be real, there's not a lot of developers out there that leave decent comments, so it's not like you can exactly know what data is coming in and out. It's a safe bet to say that the E would be like a good save until you start to learn more about that code, and then you can make a decision based off that.
Yep. We'll be, you'll be seeing me use this throughout the semester, and it's going to become second nature to you. But it makes it so that I can make that basically I can use the same when I write linked lists, when I write trees. I can use whatever data type I need to inside there. All right, so that should be it. I want to give people the chance to start working on it, and as well as the ability so that I can go around and make sure that you aren't stuck somewhere on this. So if you didn't watch the videos, perfectly fine. It's been a rather exciting weekend, right? So what you want to do is remember, before each Tuesday, we have a module, and you want to watch these videos over here. If you are, and I do, so again, there's 9 videos here. This video, 3 minutes long, very good overview over it. A more detailed overview of how to use these things from 2 to 5. Videos 2 to 5 will let you answer basically most of the questions on the homework. Videos 6 through 7 is required for figuring out why you're getting the question wrong on the last problem in the homework. And just to give you a heads up, this used to be an exam question, and then I took it off the exam because it was not fair for an exam, because only 1 or 2 people would ever get it right for full credit. I normally would have to take 3 points off because I'm going to say, well, it works in most cases, but in the example I give you, it does not actually work. And I would give like 7 out of 10 points. So just be warned. So that is why so it requires you understanding how those things work internally. And that is one of the questions that when you demo it, we will be asking you, how did you solve this? The students typically solve this in 1 of 4 ways. And then one of the other, and then we'll choose one of your other methods to just kind of at random to look at. So, all right, that should be enough.